oftentimes when a metal and a nonmetal bond and form an ionic bond, the ratio of cation to anion is not 1-to-1. So let's look at a few examples of compounds that do not have 1-to-1 ratios between their cations and anions. One example is the compound calcium fluoride. You probably noticed from the first example that we looked at in the other video that ionic compound names do not use prefixes. So there's nothing in here that tells us how many calciums go with how many fluorides. But we can figure it out by looking at the electron configurations from the periodic table. Let's take a look at calcium first. Calcium has 2 valence electrons. And as we talked about in class, any element that has a low number of valence electrons, like 1, 2, or 3 valence electrons, will lose all of them. So what's going to happen to calcium is that it will lose its 2 valence electrons, and it will become a calcium ion, which has a +2 charge. In chemistry, we tend to write the charges with the number first and then the positive or negative afterwards. So you can see that I wrote this as Ca2+. You could write it as +2, and it would be equally correct. Now, fluorine is the atom from which fluoride forms. And we know that fluorine is a halogen, so it has 7 valence electrons. Okay, all nonmetals have somewhere between 4 and 7 valence electrons, except for the noble gases, which already have their 8 valence electrons that make them very stable. So nonmetals, like fluorine, tend to take more valence electrons until they can fulfill the octet rule. So fluorine is going to gain 1 electron, which will give it a -1 charge. And as mentioned before, in chemistry, we just write negative, we don't write -1. So now you can see that calcium and fluorine are not going to be able to bond in a 1-to-1 ratio because we need calcium fluoride to become a neutral compound. So what we have to think about is how many calcium cations should go together with how many fluoride anions. And you probably can see that if we just added a second fluoride anion, then we could neutralize the charge. If we have 2 positive charges from the calcium and 2 negative charges, one coming from each fluoride, we will neutralize. So the formula for calcium fluoride is 1 calcium and 2 fluorides. In other words, CaF2. This is a neutral compound, and we are finished forming it.